Good morning. My name is Molly Tenbrook, and I want to thank you all for joining us today for our webinar. Before we jump in, I would like to give you a brief introduction to Trilogic and what we do. For over 30 years, Trilogic has provided software and services enabling engineering groups to design, develop, and deliver products through excellent support, training, and consulting services to help you achieve success sooner. Oasis Sales has been a mentor premier partner for over 16 years. Their industry knowledge and experience make them uniquely qualified to understand your business and how technology will make your customers successful. As you can see here, highlighted on the map, are the regions that each Oasis and Trilogic cover. Here you can see the different design and product management areas that Trilogic covers. You'll notice that we have tried to create a suite of products that will provide a front-to-back solution all the way from concept to end of life. And now just a couple of housekeeping items. You can open and close your control panel with the small arrow at the top on the left. There are two ways to join the audio. You can either join with your microphone and speakers or telephone. The instructions, if you wish to switch, are in the audio section of the control panel. Today's presentation is being recorded and should be available within 48 hours. All participants will be in listen-only mode during the presentation. Please submit questions via the question panel in the GoToWebinar control panel. And now I would like to introduce our presenter today, Walter Goody. Walter has over 25 years of experience in the ASIC and FPGA design and holds an MS in electrical engineering from Washington University in St. Louis. He worked for 6 years doing ASIC design at Tellabs Operations. From there, he went to work for Mentor Consulting, where he consulted on various ASIC projects, including time spent in München, Germany, and Helsinki, Finland. For the last decade, Walter has worked as an application engineer supporting Mentor's line of functional verification projects. Please welcome Walter.
Today's webinar is going to focus on coverage, and particularly on code coverage and how we can use that to test how effective your test bench is on testing your design. So first of all, when you talk about coverage in RTL simulation, there's two basic types of coverage that you can talk about, and both of them provide a measure of the completeness of your verification. So the first and the focus of today's webinar is on code coverage. And code coverage is really just measuring how effectively does your test bench exercise your RTL code. And then the next type of coverage is called functional coverage. And that is more, has your test bench tested all of your requirements, is what functional coverage is about. So code coverage is just, have you exercised the design fully? Functional coverage then adds the functionality of your design into it. So you really need both types of coverage to get a complete picture of your design. But today's webinar is just focusing on the code coverage part of things. It's really about, have you executed all the executable lines in your code? Have you taken all the possible branches in your if statement? And then you get into more complex coverages like conditional coverage that tests, have you branched in all the possible ways? You get finite state machine coverage, where you actually can look at any extracted finite state machines in your design and see if you've hit all the different states and whether you've covered all the possible transitions in your finite state machines. So there's all kinds of coverage. Toggle coverage, it's kind of debated on whether you need to do toggle coverage. Some people like to at least get an idea that they've at least toggled most of the signals in their design. So the good thing about code coverage is it is built into any version of the simulator that is sold by Mentor Graphics. So if you've got the Altera version or the Atmel version or Microsemi version, Those do not include code coverage, but if you buy anything from Mentor Graphics, so ModelSim PE, Questa, Questa Core, Questa Prime, they all include functional coverage. And you don't have to change your code or your test bench in any way. You just can turn on the code coverage and see what the results are. And it's all about, again, have I exercised my RTL code completely? Is there any code that isn't being tested? Do I need to create new tests to cover different things? And you can use it with a regular directed test bench, or you can use it with like a randomized test bench, like a UVM or something. So to turn it on, what you do is during your compile stage of your design, you use the plus cover option when you compile your code. And if you just say plus cover, you will get statement branch, conditional expression. I believe you'll get finite state machine and maybe toggle as well. If you want extended toggle, you can turn that on instead. So you have two options when you use that plus cover in your compile. You can just say plus cover, and that'll grab all of these, or you can say plus cover equal, and you can give like FB, CE, F or something, and that'll collect those. Okay, so it's right there. All options except X are when you use plus cover. So that's probably what you're going to do. So like I said, the first type of coverage, and this is a view of the XML details that you would get if you wrote out an XML report of your coverage, is it shows all the executable lines of code in your RTL, and it flags, you know, green if it's been covered and red if it hasn't been covered. Branch coverage is similar. You know, this is just showing a flow diagram of some code, and so branch coverage is just going to look, and it's going to say, have I branched both true and false in every possible branch? Have I taken all of the branches in my code coverage? And I think this is actually a view from our HDL designer tool with the coverage stuff annotated on it. And it's basically showing, you know, if I run my code, you know, it traces each one, and then it says, okay, I've taken that branch, I've taken this branch, I've taken this branch. And it basically goes through and it tells you, you know, have I covered all of these different branches? Then we get into what's called conditional coverage for if and branch statements, and expression coverage is for concurrent signal assignments where you have like a true false built into there. So they're basically kind of the same, but one of them's for if statements within a process or an always block, and the other one is for testing the conditions of a contiguous signal assignment. And so what that's doing is, now if we look at this statement right here, if memop done equals 1 and CPU read equals 1, then branch true. So if both of those are true, if both of those are a 1, we branch true, otherwise we branch false. So there is only one way you can branch true, and that is if both this and this are a 1. But there's 3 different ways you can branch false. So you can branch false if this is a 0 and this is a 1, if this is a 0 and this is a 1, or if they're both 0. And so a conditional coverage is going to look at that full matrix of ways you can branch, and it's going to do a coverage that says, well, you branched false only when both of them are 0. And, you know, you've written that for some reason, so, you know, why are we going to do that? Now, when you talk about this conditional and expression coverage, there's 2 different ways that you can get that coverage. And the first one's called UDP coverage. And that is what I was just saying, is that you build up this table. So if we look at this assignment right here, you know, there's the only way to branch true, well, actually, if A and B are 0 and then C is a 0, you're going to branch false, or if A and B is 0. Then you have, like, if C is a 0, you'll always be 0. So if both of these are 0, you'll branch 0. If C is a 0, you'll branch 0. If A is a 1, B is a 0, and C is true, you'll branch true, etc. So you have that coverage. That was the older style of doing things. There is now something called, so it's basically a truth table, and you'll have 2 to the n patterns in there, and you calculate the branching on that. The newer way to do it is what's called focused expression coverage. And what that does is it creates a table, and so now there's 3 different elements in here, and we look at the effect of, A being a 0 and A being 1. Then we look at the effect of B being a 0 and B being a 1, and then C being 0 and 1. And so any one of those, it's basically you're looking for when does C have an effect on the thing. And so any of these 2 conditions will fulfill that table. So the default now is this FEC coverage. So don't worry too much about that, but it's, just a couple of different ways to collect that conditional coverage. We also have finite state machines in our design. So we do a finite state machine coverage. So finite state machine coverage is, have I hit all 4 states here, and have I taken all 5 of these different transitions? That's a complete coverage. So how do we implement this coverage? I already kind of alluded to it. When we compile our design, we use the plus cover, and then optionally we can say what we're looking for. So in this case, all of the files that I compile with this command will be collecting finite state machine coverage. For this one, all of the files in all the VHDL files in this file list will have all of the different coverage collected. And then if you're doing Questa and you have the VOP command, you can optionally do the plus coverage during the VOP phase of your design. So it's one of 2 places to do that. And then finally, when I run my simulation, if I use the dash coverage option on my test bench, what it will do is it will go back and it will say, when I compiled this, these Verilog files we were collecting finite state machine coverage. The VHDL files in this design, we were collecting full coverage. And so when I say VOP, or when I say VSIM, it basically elaborates the design, and whatever coverage I implemented either during the compile or the VOP stage will be collected, and we can then analyze it. So I'll show that to you. And then once you've run the simulation, so I brought up the simulation, I brought it up in coverage mode, I've run the simulation to the end, and it has collected a bunch of coverage. What I want to do before I quit my simulation is save that coverage database. So I save it into what's called a unified coverage database. And the reason I do that is if I am running multiple simulations in my regression suite, what I can do is I can bring those up and I can merge that coverage into a cumulative coverage over the full regression suite. So that's the coverage saved to a database. I can generate coverage reports both in text format, or I can see here I did a cover report, and that was, live in my simulation before I saved. Or I can do a vCover report and say, grab all the data out of this UCDB and create that coverage report. I can also write out that coverage report in HTML. So this is just in text format, and that's maybe to include in a database that you're going to use for your design review. The HTML report, it will grab all the information out of this coverage database, and it will create an HTML website that you can point someone to, and they can just, with a web browser, look through the coverage reports. So there's a lot of different options in there. Once I create that HTML database, you'll see I end up with this cover HTML report directory, and I can go into there and I can click on any of these HTML links, and that'll bring up a browser, which will then like show me the hierarchy of my design. I can browse down into the hierarchy of the design, click on any one instance. It'll show me what the statement coverage, the branch coverage. In this case, I collected the FEC. You can only collect one or the other, FEC or UDP, and toggle coverage on that instance. So all of that coverage information that I'm collecting, that code coverage data, and if later on I do other types of coverage, functional coverage, assertion coverage, et cetera, those all go into these UCDB databases. And so you store that information in a UCDB. And then in the GUI, what I can do is I can bring up this verification management browser. And you'll see this is, I've added, what, 7 UCDBs into this browser. And each one of these has its own set of coverage. So I ran this test and I got the coverage hit. And I got, statement coverage, branch coverage, state machine coverage, FEC coverage, toggle coverage, etc. So I got all that coverage for each one of these tests. And that's interesting, but what I want to know is, what is the coverage of all of those tests? So to do that, all I have to do is in this browser, I can select here and I can shift select down here. So now I have all those databases selected, and then I can right click and just say merge those. And so when I merge those, now I get the cumulative, it takes all the statement coverage from all these databases and it combines it into a single merged UCDB. So now instead of, all these different coverages, I can see my whole test suite is getting 99.4% statement coverage, 99.05% branch coverage, etc. And then I can bring up this database and look at what I've missed. And so finding the missed coverage is, for statement coverage, you can bring up the source code and you can look in the source code window and you'll see there'll be a column right here for each executable line of code. It'll tell me if I've already hit it, you'll get a check mark. And if I've missed that statement coverage right there, I'll get a, it'll highlight that statement in pink and it'll say you haven't covered that statement. Right here is I've missed some branch coverage. So it's telling me here, I have missed the branching true of this statement right here. So that's kind of a view of the statement coverage. If for some reason this is a statement that you've put in maybe for completeness, so like if you ever, have a thing, maybe you always should have a be write or a be read, but I've just put in this statement as a placeholder just in case something weird happens. You can put in these dash coverage on, coverage off, and that creates an exclusion to exclude that branch and that statement. And this might not be a good case for that, but you have to come up with some kind of reason for these exclusions. But now I put in that exclusion and you see I have 100% coverage in my design. So analyzing the coverage is, like I say, there's a few different windows you can look at. For code coverage, you can look at the source code, and I already said you can see the statements that aren't covered and the branches that haven't been covered. There's also what's called an analysis pane, and that analysis pane allows me to do some filtering on this. So the source code window is just going to show all the source code, and it's going to either show checks or X's on all the source code. The analysis pane allows me to use these filter buttons to say, I don't care about the covered. I just want to know for this instance of this design, what are my uncovered things? So I can turn off showing the covered designs, and it shows me that I've missed 4 different statements here. And then if I was looking at, say, conditional coverage on this if statement, I can come over here to the details window, and it'll show me the full graph of all the different possibilities and, you know, what things have been hit and what things haven't. You also can look in the instance window, and you can see the individual instance coverage of all the different modules or entity architecture pairs in your design. As I said, the analysis window, by default, it'll show all my code. It'll show all the hit statements, all the miss statements, and it'll tell me any exclusions that I currently have. And then I can use this little filter button to filter out the hit thing, so I'm only seeing the miss thing. So this analysis window for any instance of code, so in this case, it is the controller that I'm looking at. I have it on statement. I can click that button here, and I can say, okay, I want to show the analysis of branch coverage, of expression coverage, of FSM coverage. And it gives me different views in this details pane, or in this analysis pane, that talk about these different pieces. So right now I have it on statement, so it's showing me the statement coverage, showing me the covered statements, the uncovered statements, and the excluded statements. So the way I do this is I can go through and look at the hierarchy of my design. I can pick any one instance, and then that will show that thing in the instance window. So right now I'm looking at the conditional coverage of this processor RTL, and it's saying that there was one conditional statement and that's uncovered, and I can look down here to see this full spec graph of, you know, what that coverage was, and I can see what's been covered and what hasn't. And so there's what, 1, 2, 3, 4, 5, 6, 7, 8 different coverage paths through here, and only 2 of them are covered. And so that should come up, doesn't actually show it here anywhere, but it basically will say that I have 25% coverage on this particular design. Actually, I guess you need to hit both 0 and 1 to be considered covered. So this is saying there's 4 inputs, and none of those inputs are covered, because this one is covered for 0, this one is covered for 1. So that's the coverage analysis. I'll show you this live after we get through the slides. Code coverage in the source window is, like I say, it's quite easy. It will show in the source code window. The source code window always highlights any executable line and shows the number of that line in red if it is executable. And then if you're doing coverage, it will show statement coverage. It'll highlight things that aren't covered in pink. Branch coverage the same way. So I've got this case statement, and I can see, you know, these 4 cases are covered and these 4 cases are not covered. If you hover on any one line, you'll see both the statement coverage, how many times I've hit that line of code, and then it's saying that I've hit that line of code 394 times, and I branch false 394 times, and I branch true 0 times. And then the coverage detail gives you the same kind of information in the analysis and details thing. So here's how I usually like to look at coverage. This is the SIM tab that you normally have, where you can look at all the instances in your design. And you'll see that right now it's showing that chip has 100% coverage. So that is, this piece of RTL has 100% coverage. This controller has 76% coverage. This TX processor has 72% coverage. This is showing the instance coverage of each instance in my design. I usually like to, so you can also see that if you bring up the instance window in your design. Statement coverage, we already talked a little. You can look at it in the source code. You can select that guy, double click, you'll bring up its source code. If you look at the coverage analysis, you'll see we're in statement mode. We see the covered statements, the uncovered statements. And then if we click on one of those, we get details about that. If we go to the branch coverage, we look at this, we see that in the details, we now see this branch wasn't covered, and we see that, we never took this false path in this if statement right here. And then conditional coverage, this is one where, it's showing that it's saying I have 50% coverage on this statement right here. And so the reason it's 50% coverage is I've taken the path where memop was 0 and memop was 1. And then what I haven't tested is I've taken the path where control CPU read is 1, and that's affecting the outcome. But I've never had CPU read being a 0 affect the outcome. So that condition is only 50% covered. And so for this whole thing, you would have some conditional coverage for this whole module. Finite state machine actually has a dedicated window for looking at finite state machine coverage. So here I've brought up a finite state machine viewer, and I see there is this module called frame source state, and it has a finite state machine in it. And hopefully you can see this, but you'll see the idle, the ring around idle is black. The ring around this post processor is black. And all of these other states, the ring around them is red, which means I've never been in that state. And that, then the transitions here, you'll see I have a black transition up to here and a black transition back. And then the staying in idle, that transition's been taken, but none of these other transitions have been taken. So that's just sort of a graphical view of this finite state machine coverage. And then this window, if you're in a live simulation, you can actually start walking through the state transitions. And I don't think, actually, you don't have to be in a live live simulation. You just have to have recorded all those states in the wave database, because you can move both forwards and backwards and trace the state transitions that are in your simulation. So, a lot of people talk about, well, how much coverage do I need? And this is just kind of a little bit of a graphic of that. This roof has 95% coverage. Is that enough? You're still going to get rain into your house if you have 95% coverage. So, for the most part, we say there should be 100% coverage. So how do you get to 100% coverage? And that is that you do a review of your design, and you review all of the code, and you find any uncovered lines of code. And then if they are uncovered, you either have to write some stimulus to cover them, or you have to create an exclusion. And then usually you have to give a reason why that line of code was excluded. And so there's a few different ways to do exclusions. You can put it as comments, as pragmas in your code. So if there is this block of code, and for some reason you don't want that included in your statement, you can put a dash coverage on and a dash coverage off around that statement. And in this case, I did a coverage off B, which only turns off the branch coverage of that particular block of code that I've done here. And maybe it's because you don't, in this case, you don't want to test the reset part of this. You only want to test the next state logic. I don't know why you would do that, but in this case, that's what that is. The other way you can do it is you can post-process. You can collect the coverage, and then you can create a set of coverage exclusions. And so these are pickle commands that you can put in your script that say, in this case, let's exclude the statement coverage on this VHDL code line 138. And let's exclude the branch coverage on that same VHDL code line 89. So that's naming the file that you want to exclude. You can also do it by design unit. So in this case, I have a design unit called TinyCache VHD with a architecture of FSM, and I want to exclude the finite state coverage branch of being in the write mode and going to reset, whatever. So these are just some examples of exclusions. So you can exclude lines of code, you can exclude states and branches, expressions, you can exclude pretty much any type of coverage. And so the whole idea is that the verification management here is that we're going to do some analysis. We can do that in the Tickle GUI of the simulator, or we can generate these HTML reports that allow people to look at an example of that coverage and, you know, do some analysis offline, but they don't need to own the tools to do it. So this is good if you have third parties, maybe engineers in another division, project managers, something, who they don't have access to the tools, but they want to look at coverage information. You can generate either text or HTML reports of all your coverage. So then a couple of things I want to point out is that there is a tutorial manual. If you go to the help in ModelSim, you go to help, PDF bookcase, pull up the tutorials. There's a whole chapter on simulating with code coverage. And it has it has a VHDL example and a Verilog example. So you can pull the code out of the install directory and you can, you know, play around with that coverage tutorial in order to get familiar with coverage. So code coverage, as I said, is that first step in doing coverage. It is finding unexercised code. You can just turn it on. You don't have to change anything about your test bench. The next thing you can start to do is start to go into that functional coverage part of things. So that is using either, this is procedural coverage where I'm looking at sequences of events on different signals. And that is going to be either using SystemVerilog assertions or PSL code, property specification language, which is part of the VHDL spec for the 2002, I guess, version 2008 version of VHDL. So Coverdirectives and assertions provide coverage information about procedural events within your code. And then SystemVerilog Covergroups are data coverage within your design. So let me give you a couple of examples of that. So what kind of stuff do I want to collect this functional coverage on? And if you look at a design, you can look at individual units within your design. So let's say you have a FIFO. You can, you know, write either assertions or cover directives that are monitoring the events on that FIFO and seeing if you've ever done a read when the FIFO is empty. If you've ever done a write when it was full. Have you filled it up all the way? Is it big enough? You know, is it operating like a FIFO, first in, first out? State machines, you might write some assertions to say, have I ever taken illegal transitions in my state machine? Buses, you might want to monitor the protocol on some buses to make sure that the traffic is legal or that you're handshaking correctly between these two blocks. So all kinds of stuff like that is what you're going to be writing functional coverage to do. So functional coverage, unlike code coverage, is not automatic. You need to write these cover directives or assertions in order to collect that coverage. And it's actually validating the functionality of your design. So it's not just have I exercised my design, but it is my design operating as I expected it to? And so in a lot of ways, functional coverage is more powerful, but it is some work on your part to create these things. So let's take a look at a couple of things. So functional coverage with SystemVerilog and PSL, if you're using the cover directive, that is looking for sequences of events. So for instance, I have a write sequence. This one is SystemVerilog. Let's start with this one. And it's just covering the write sequence. And it's saying pause edge of clock is what's walking me through my sequence. And I want to see the sequence that address strobe goes low, and at the same time, read write is low. And then one clock cycle later, address strobe is going to go high, read write is going to remain low, and I'm going to look for the ready signal to toggle low. And I'm going to wait for up to 4 clock cycles for that to happen. So I'm going to wait between 1 and 4 clock cycles. And then, you know, the ready should go low, the address strobe should remain low, and our address strobe should remain high, and the read write should remain low. So that's the sequence for a write. So I create this cover directive, and it's just going to monitor these signals. And every time this sequence of events happens, it's going to increment that write sequence cover point. So this is PSL, and you'll see it's very similar, but it's just using VHDL-like constructs instead of Verilog-like constructs. And so I'm looking for cover sequence. You know, I'm looking for the address strobe. In this case, the read write is high. I look for this sequence of events, and it will increment that read counter. And then what I can say is, I want to see 10 reads and 10 writes before I consider that bus covered. So that's creating, you know, that's something that you write, you bind it to those signals, and the tool will collect that coverage for you. Cover groups are, what they do is you can have things like, you have a write strobe that has a, you know, like either going to be a 1 or a 0. And then my address, I have 256 different words in my address. And so I'm going to create a cover point on that write enable. I'm going to see if bus operation happens, and I'm going to count how many times it's a read and how many times it's a write. And then right here, I'm going to create a cover point on my address. And every time I have a bus cycle, I'm going to look at what the address was. And I'm going to count all of those different addresses. I'm going to say, have I written to 0? Have I written to 1? Have I written to 2? And then down here, I have what's called a cross coverage. So I'm crossing the cover point I did on my read write enable and my address. And what that's going to do is it's going to create a matrix, and it's going to say, have I done a read to every address? And have I done a write to every address? And that then brings up something that looks sort of like this. So for each cover point, you know, I'll say, have I covered this different thing? This particular cover point right now, it's saying it's 80% covered because I've gotten these, but I haven't hit anything on that particular one. This cover point is fully covered. This cover point is 83% covered. Excuse me, that's the cross between these, so it's that matrix, and it's showing, you know, how well covered that is. I don't want to go into a lot on functional coverage, but what I do want to say is, if you have never gone there, I really encourage you to go look at the Verification Academy. If you do a search on Google of Verification Academy, this will be your first hit. And it is a free website. It is sponsored by Mentor Graphics, but it's free. You don't have to own Mentor Tools to get into it. And it has a bunch of different things. So it has a bunch of different tutorials on different verification topics. it has a couple of different cookbooks. So there's a coverage cookbook that all talks all about coverage and those kind of things. And then finally, there is a user forum that is like an open forum where you can ask questions and get answers. And all of our verification gurus kind of monitor that forum. So 90% of the time, if you ask a question, it's going to be an expert from Mentor Graphics who answers your question on that forum. So first of all, the courses, the one that I would encourage you to look at if you're not currently doing code coverage is this evolving verification capabilities. It talks about a lot of just basic topics in getting started with collecting coverage in your test benches. So that's the first one I would direct you to. There's another one on some steps you can take in evolving your verification methodologies. I don't see it on this list, but anyway, go to Verification Academy, take a look at these courses. The thing I like about these courses is they are not super long because they are serialized. So each one of these chapters is like a little 15-minute chunk, and we keep track of where you are. And it's better than, we put out a 3-hour webinar, nobody's going to watch it. But by putting these in serialized forms, you can sit down, watch it while you eat your lunch on Tuesday, come back on Thursday, watch another chapter, come back the week after, watch another chapter. It is more consumable in like today's short attention span world, let's say. So then the other thing we have are these cookbooks. We have a UVM cookbook, which is a reference manual for doing a constrained random SystemVerilog UVM test bench. But, you know, and that's fairly advanced. The coverage cookbook is a little more accessible for your everyday FPGA engineer. It just talks about what is coverage, how to start collecting it, how to start collecting code coverage, how to write coverage test plans. So I find that to be a really good book to look at. So really, if we look at coverage, code coverage, there is no reason not to run it on your test bench. If you own ModelSim or Questa, turn it on, run your test bench, and I guarantee you, you will find lines of code that are not covered that surprise you. So it's easy to use, just turn it on. Then once you start to do more complicated coverage, what it can do is help you to say, you know, I'm running this test, but it doesn't seem to be providing any more coverage information. So why am I running it? And it's really like having a map. Helps you understand where you are and where you need to go to get, you know, full coverage. Look at the code coverage module on Verification Academy. So there's the link for that. And then once you've looked at that, look at the functional coverage metrics module on Verification Academy. So a couple of different Verification Academy things. And really, code coverage is easy. Turn it on. We have a complete set of tools for doing analysis. There's lots of technical things to help you get deployed. Let me just pull up ModelSim real quickly and show you a quick example. So I pulled up ModelSim, and then I have this directory right here with some source code and some scripts to run stuff. So if I was to want to get to there, one thing I like to point out to people is if you look at Windows, if you just paste that directory and you try to CD there, it doesn't understand it because there's all kinds of characters. After a couple of years, I discovered is if you put that path in curly brackets, you will actually be able to do that CD and go directly to that directory. So just something I wanted to point out. So I have a compile here, compile script. So let's run that. And while that's running, to compile that too, let me just bring that compile script up real quick. So if I look at this compile script, you'll see that basically what it does, it's creating a work library. It's collecting all the coverage on these 3 Verilog modules, and then it's collecting all the coverage on all of these VHDL modules. And then you'll notice my test bench, I am not collecting coverage on that. That's because I don't care about coverage on the test bench. I only care about coverage on the unit under test, as it were. And then let me show you the run script real quick. And that is just, I am saying vsim dash coverage, and I'm, running that test module. If you are running in Questa, that does this VOP stage, which optimizes your design. And so if you're doing coverage within Questa, you do need to put this argument that will preserve visibility and allow the coverage collection to be done. Let me just bring up the tool real quick. Do run. And so now you'll see I bring up the tool. It's in coverage mode. And I actually ran 100 microseconds of simulation. So not a lot of simulation, but let's look at the sim tab here. So this is the hierarchy of my design. So here's the hierarchy of my design. So first, I've got it in instance coverage mode. So what we see is, it says that the delta, the top level chip RTL has 100% coverage. All of these instances have 80% coverage. And if I start to go down, I'll see, at some point I get down and I've got some other things. This guy has 75% coverage, that has 70, this one has 20% coverage. That is showing, as I said, the instance coverage. But when I look at this hierarchical view of my design, what I actually like to do is come down here and enable recursive coverage sums. And what that does is now you'll see it says chip has 78% coverage. And that is the hierarchical roll-up of all of the instances in my design. And so this 78% is the cumulative roll-up from the bottom of my design. And that's, to me, is more interesting because I'm interested in what the total coverage for my chip is. So let's collapse that. And then let's look at a few different lines of code. So I had my wave window here before. Now let's go and let's look at one of these designs. So let's come down here to this bit of Verilog code. And if I double click on that, you'll see I can look down through there and I can see all the different lines of code. I can see which ones have been hit. And I can see that I've never branched true on reset. So I've never hit the reset on my chip. That's interesting. And then I come down here and I can, see some other places where I haven't had coverage. But, that's hard to look at in some ways because I got to look at all of this code and go up and down. So instead, I'm going to come over here to this coverage viewer and I'm going to turn on the analysis pane. So I've still got that instance selected, and that's all my lines of code. If I turn off the exclusions, I can see these are only the uncovered lines of code in my design. And I can, then look at those, and if I double click on them, I can go to those lines of code and find out what's going on with those. And you know what? In this case, I'm looking and I'm seeing that that is a case statement, and I have this default case. And that default branch right here, I don't actually need to cover that. That's just good coding practice. I don't actually ever expect to do that. So I can actually select those and add exclusions. I could put those dash cover on, cover off around this. So there's a whole bunch of different ways I could exclude that code. Let's look at maybe this piece of code. So again, I can look at that in the source window, but it's kind of hard to tell. So maybe I'll go over to the analysis pane and I can see what are my uncovered lines of code. And I can look at those. Now that's interesting, but let's look and find one that has, so this guy has both some conditional coverage and it has some finite state machine coverage. So I'm gonna remain with that selected, but I'm gonna look at the conditional coverage. And you'll see I've got all these different branches that I've missed conditional coverage on. So this is an interesting one. Let's click on that. And that then shows me the details over here. So you'll see there's 4 different variables in this if statement. And it takes each one of those variables and it says, have I looked at the effect of this guy being a 0 and a 1? Have I looked at the effect of this one being a 0 and a 1? And this one, and this one, and this one. And you'll see that I've only hit the 0 on the reset and the 1 on the test mode. So from a effect point of view, this has 0% conditional coverage. Let's look at this one. That one's 0%. I'm just looking for something that has a little more coverage. I probably need to run this simulation a little longer. So a lot of these don't have coverage. That's the coverage here, the effect coverage. And then let's look at finite state machine coverage. Let's turn this to finite state machine. So I can see that I have this finite state machine. It has 3 different states. I've only hit one of them. And then I've never taken any of the transitions out of that finite state machine. If I look at this finite state machine list over here, this is that one. So if I click on it, I see there's 3 states. I've only been in this state. I've never taken any of the transitions. Let's look at this one. It's maybe a little more interesting. Let's make that full size. And zoom full. And I can see in this one, hopefully you can see the states here where they're outlined in red and shown in red. Those I've never hit. I've only been in idle and post-processor, and I've only taken the transitions back and forth between them. And all these transitions in red, I haven't hit, and all these states in red, I haven't hit. So if I ran more code coverage, I'd probably start to, see more of that getting covered. That's kind of just a quick run through of some of the coverage. I'm going to head over to the chat window and see if anybody had any questions. Will all ModelSim and Questa tools do code coverage and functional coverage? So all ModelSim tools that are sold by either Mentor or Trilogic, your distributor, or Oasis. So if you're buying it and it's from Mentor Graphics, it will have code coverage. The ones you get for free from Altera and from Atmel and Microsemi, those do not include code coverage. Functional coverage, you will get the assertion coverage if you have ModelSim DE or above, and you'll get the cover directives with ModelSim DE and above. The cover points, you need to have either Questa Core with the functional coverage option or Questa Prime to get those. This says, can you handle constrained random testing? And so constrained random is doing SystemVerilog constrained random testing. And that is only supported by Questa Prime, the actual constrained random testing. But that is independent of whether or not you can collect code coverage information or assertion coverage or cover points and cover directives. What was the command you issued to bring up the GUI window on the screen? If you're in a terminal and you have the correct path set up, you can just type vsim, and that will bring up the GUI, or I think I did it actually by just clicking on the icon in the start menu. So yeah, I think that's it on the questions. So I want to thank everybody for their time and attention. I really appreciate everybody who hung in there till the end of the seminar.
Thank you everyone for attending today. As we said earlier, a recording of this webinar will be available for you within a couple days. So just watch out for that in your inbox. And thank you so much for attending. And thank you, Walter, for your presentation.